Today we are covering the remainder of lesson 9.4 on parametric equations and lesson 9.5 on polar coordinates. Now, as you'll notice, this looks a little different from your notes because I have blocked out the work I've already put in so that you don't need to see me trying to graph some of these detailed graphs just by sleight of hand. So starting off, we solve for t in this equation to get x equals 2t. Well, using logarithms, log base 2 of x equals t. So we get this equation, and then we're going to plug that into the next one. So we get y equals 2 to the 2t, so 2 to the 2 times log base 2 of x. And because this is kind of a log, we can move this 2 so that it's log base 2 of x squared. And then log 2 times log base 2 cancels, right? Because 2 to the log base 2, this is just, again, this stands for the exponent, such that if you raise 2 to that exponent, you get x squared, and so we get y equals x squared. Now from that, it's not the same as the previous graph because t has limitations here. So we'll fill that up there for our x, y equals x squared, and then down here we have our chart. So t is -2, and we're plugging t back into x equals 2 to the t. What is 2 to the -2? Well, that's 1 over 2 squared, 1/4. Now, if you remember this value cannot equal 0, right? 2 to the -10 is still 1 over 2 to the 10. So we get 1/4, and then plug in -1. 2 to the -1 is 1/2, and we're multiplying by 2 here. That's what's happening. So times 2, 1/2, times 2, 1, times 2, 2, times 2, 4. And sorry, this is -2, -1, 0, 1, 2. The last two look like it got cut off just a little bit. And then we're squaring these. So 1/4 squared, 1/16. 1/2 squared, 1/4, and so on. 1 squared, 1. 2 squared, 4. 4 squared, 16. And then we're plotting those points, and we get this upward trend. Now we are not equal to 0, 0. Why? I made this little note down here. X cannot equal 0 because no, so we're not going to do an arrow both ways. We will do an arrow up. This will continue. T only had the limitation that it cannot equal, T could not make X equal 0. Now the next type of questions were one that some may have already tried to finish, however, very particular. We need to find two different sets of parametric equations for the given rectangular equation. Now, right, we're going to have x equals some number of t and y equals some number of t as well, such that when we put them together, we get 2x plus 1. Now, this is actually a pretty simple thing. However, plenty of people are like, how do I need to cop my way out of this? And what is not acceptable? Yes, I need to tell you what is not acceptable first. You cannot just say x equals t and then just, y equals 2t plus 1. What do you know? It works, right? Same thing with negative t. That's a little too basic. In the past, I may have accepted, but oh, negative t, plug a negative t, this switches your sign. And so how does it work is the question, right? What I want you to do is pick, x equals some number of t, let's say 2t, and when we pick that, we're then going to plug 2t into here. Well, if x equals 2 times t, now this is going to become 2t, and we get 2 times 2t plus 1. We substitute it in where the x is, and I get 2 times 2 is 4t, so y is 4t plus 1, and in general, I would like you to then say, here's my answer. X is 2t, y is 4t plus 1. Now, I needed 2, right? There's 1. Maybe you can choose to do, and again, it's not coming out. X is t squared, and then 2 times t squared is 2t squared plus 1. We also could have done x equals t plus 1, and then you would plug t plus 1 where the x is, 2 times t plus 1, 2t plus 2, and then we have another one, so 2 plus 1 is 3, and we get 2t plus 3 when x is t plus 1. And we do one more of these for lesson 9.4, and then we move on. X squared plus 4x minus 1. So you could say, how about x is 2t, 2t squared is 2 times 2 is 4t squared, and 4 times 2t is 8t minus 1, where x is 2t. And my other choice, I chose minus 3t, right? So it's not just minus t, but switch the number up. And how does that affect it? Well, minus 3 times minus 3 is 9, t times t squared. 4 times minus 3 is minus 12t, and the minus 1 just kind of follows along for our final answer there. And that was a wrap up of 9.4. 9.5 is polar coordinates. Now, polar coordinates is another coordinate system where I could use r and r for radius and theta for an angle measure to find an endpoint here, such as P, right? So polar coordinates use the pole. So we are set around O for the origin. The pole is the origin, and the polar axis is this line right here. This is the polar axis, kind of like our unit circle, the positive x-axis. Right here, symbolized. Oh, it's not wanting me to write here. There we go. This one right here, the polar axis. This would be, again, the terminal side, and polar coordinates are very similar to some things we've done with vectors, some things we've done with imaginary numbers. Again, a lot of these equations will sound familiar. The graphs are just going to be a little different. So r is, again, the directed distance from our origin to the point P. And theta is the angle to get there, counterclockwise from the polar axis. And again, just like with previous lessons, you may need to pause in order to get the vocab written in. That is perfectly fine. And now to plot the point, now this is different. This is a circle. So how does this system work, right? So our 0 is like going this way for angle, right? And our radius is actually, each circle is radius. So for example, I labeled it in purple here, R, this is ring 1 is radius 1, ring 2 radius 2, and 3 and 4, 5, 6. Now you will notice quick if you look at my first polar points that I have negative as well. So what negative is going to do is it's going in the it's going to go in the direction opposite of 4 pi thirds. So I'll explain that when we get there. But starting off, we've got 4 2 pi thirds, right? Again, r theta, that's how the points are. R is ring 4 or radius 4, so it's going to be on this ring. And then we're going to look at our points. Now, I didn't show you the points yet, so this is actually split into 24 sections, right? So I'm going to scoot it over here because it seems like it's going off the page. But what we have here, keeps wanting to grab everything, sorry. There we go. What we have here is that we've got 0. We don't do that one, that's pi 12th. Then we have pi 6, 2 12ths is 1 6th. And we've got pi 4th, pi thirds, and then we're skipping another one because if this is, right, if we change this into 12, we got 1, 2, 3 12, 4 12, 5 12 we don't have in our unit circle. 6 12 is half, right? That makes sense. 7 12 not in our unit circle. 8 12 would be 2 thirds. I might not worry about the pi. I'm just going to worry about the fraction, I think. And now we've got 3 fourths, all again pi, and then we've got 5 sixths, and then we just skip the one before and after our 90 degrees. So before and after, same thing here. And it would keep going 5 pi 6. Now this one's 7 sixths, and then we're going to have fourths again. So this would be 5 fourths pi, and we got 4 thirds. All right, we kind of have 3 in a row. Don't have this one, 3 halves, and continuing. So then don't have this one, 5 thirds, not 6 fourths, this is 6 fourths, 7 fourths, and 11 sixths. So graphing the point for 2 pi thirds, right? So my rings are kind of off now, so I'm going to erase those just so I could fit the graph and that information in. But 2 pi thirds is right here, 2 thirds, and the fourth ring would be 1, 2, 3, 4, and there would be point. And I'll just label it 1 for problem 1 on here. Next, we've got -3, 4 pi thirds, okay? So -3 is same as ring 3, but in a negative direction, so opposite from 4 pi thirds. So using my ring, 4 pi thirds is going over here, and so instead of going 3 towards it, we're going to go 3 away. So again, it's like this line. Sorry, it's going to be exactly 180 from my pi thirds, right? And so if this line here, I'm going to use my straight line cheater, sorry, right here. I goof it up again. Right here, this line, right? So instead of going towards it by 1, 2, 3, we're going away. So 1, 2, 3, and then my final point would be 1, 2, third ring, and there is point 2. I apologize, I do not have the smartboard access here where I'm at, so it's going to be a little sloppy with that, and I will do the best I can to draw these ahead of time without ruining the ability to teach you about it. So, other comments that are going to come in here, as much as either get it or you don't, and again, I'll try to go over this again during Zoom time as necessary, but if this is considered 4/3 -3, couldn't we also call this pi thirds, 3 pi thirds? And the answer is yes. You actually have multiple different ways we can identify the same point. And so how does this work for problems? How does this work for problems? Sorry to repeat, but had some issues. Is that we'll have, for example, the next slide, find 3 additional polar representations for the point using direction between -2 pi and 2 pi. And so we'll need this little rule up top to help us out. So our theta, our second point, can be plus or minus 2 pi, right? Whichever one's going to keep us between -2 pi and +2 pi. Now we also have these extra points here. This is where the interesting part comes in. What about -r? So we can flip radius, kind of what ring we're on, by doing the opposite direction, but then we have to switch our direction by 180 degrees or an odd number of pi. So generally speaking, I will try to plus and minus pi from the number to get to, let's say, the negative version or the opposite radius. However, you want to make sure it still lands within the -2 pi to 2 pi area. For example, this one, my first option would be I'm going to find 4 and then I'm going to subtract 2 pi from it. 2 pi in terms of thirds is 6/3, so 2 pi thirds minus 6/3, and I will get 4, -4 pi thirds. This didn't change because we were adding or subtracting by an even number of pi. Now when I switch it to an odd number, that will make it like plus or minus pi over here. If I want to plus or minus pi, I want to find 2 others, right? It says 3 answers. So here's one. I'm going to try to find 2 more. So I need to use -4. And then in this case, we added pi to 2/3 because that's 180 degrees different to get 5 pi thirds. For those a little confused, let's look back at the graph for a second. So again, we're looking at 4 2/3. I think it's the exact same point. Yep, 4 2/3, and it's other ways we could say it. So 4 2/3 right here. How else could we say it? We could say 5/3 minus 4, right? That's what I'm saying. What did we do there? We added pi by changing our direction, but then we flipped the r sign so that we're still going towards this point 1. And now I'll have to click them all just so you can see them again. And then to finish it up, I usually just, you can go with the minus pi from this original 2/3 to get -3/3, which 2/3 minus 3/3 is -1/3. And again, the point is 4 minus 1/3 pi. However, you can also, once we found this first one, subtract 2 pi, right? Whichever direction you need to do to keep it within that range. Now this next one, I'm just going to show you the answer and then explain it so I don't have to keep crisscrossing back and forth between the different slides. So explaining. First one, I always plus or minus 2 pi. So in this case, subtracting 2 pi because we're already positive direction, -6/3 again. 4 minus 6 is -2/3. So this is my -r negative set. So now I need the 2 that are positive. So to get to the positive ones, I want a plus or minus pi. Now, plus pi might not work. So 4/3 plus pi gives me 3/3, which is 7/3 pi. That is not between these two, -2 pi and 2 pi. So that one's not going to work. And so then I'm going to have to subtract pi. 4/3 minus 3/3 gives us 1/3. So there's my first positive r, positive direction. And then to find the negative, I'm just going to subtract 2 pi from here to get 3 and negative 5 pi thirds. It wouldn't hurt to use a coordinate graph. If you do have a printer, you can find those by Googling polar graph or polar coordinate system. Next, we're going to do some conversions. So to go from polar to rectangular, x is r cosine of theta, y is r sine of theta. Looks familiar, hopefully, right? From vectors and from complex numbers in trigonometric form. So from rectangular to polar, x squared plus y squared is r squared, right? And we also have x equals r cosine of theta, y is r sine of theta, and tangent is our angle is y over x, so tan inverse of y over x, and then switch around based on the coordinates. Because we've done this before, I'll kind of walk through it a little quicker, and we're already 16 minutes into the video. So we've got 2 pi 6, right? Well, r cosine of theta, r sine of theta. 2 cosine of pi 6, 2 sine of pi 6, and then what is pi 6? Cosine of pi 6 is square root of 3 over 2. Sine of pi 6 is 1/2, right? It's this point right here. And it basically tells us we're doing a 30, 60, 90 triangle where our opposite is half of that, which would be the y value is 1, and then 1 over 2, right? Sine is, adjacent over hypotenuse. And so in this case, we get 1 here, and we get square root 3 over 2 times 2, which would give us square root of 3 here, right? 30, 60, 90 triangle sides. On this other side, negative 3, 3 pi half, right? Negative 3 means we're going opposite 3, and then 3 pi half is this direction, right? Pi half, pi whole, 1.5, and then opposite 3. This looks like the point 0, 3, right? That's what I'm seeing right away. Now, you could still plug it in, negative 3 cosine of 3 pi half, negative 3 sine of 3 pi half. This is 0, this is minus 1. Negative 3 times minus 1 is 3, and there's our answer. Now, one more set. We're going to do the same idea and find the multiple points. So again, converting rectangular, this is xy to r theta, right? Well, negative 7 squared plus 0 squared is r squared, right? That's what I've got going right here. So when you get that, we get r is 7. Now, r is not negative 7. R is positive 7, right? And then when we do tan inverse of 0 over 7, right, what is this angle? It is 0, but to make up for the fact that it thinks we're between quadrant 1 and 4, when we're really in quadrant 2 and 3, right between them, right, we have to add 180, and we get 180 degrees. That one was actually on our unit circle. And so 7, 180 degrees. Now what if we went 0, and then we went minus 7. So that was the other option. We could do minus 7 at 0 degrees, and instead of going 7 this way, we'd go 7 that way and end up with the same point. Next one happened to be a Pythagorean triple. 3 squared plus minus 4 squared is 5 squared. So filled it in right away. And again, Pythagorean triple is the reason. And then tan inverse of negative 4/3, you would do that on your calculator. I do not have good access to the scientific TI calculator that you guys have for computer purposes, so you'll just have to remember that or ask me and I'll try to explain that again in a different video. Tan inverse of y over x gives you tan inverse of negative 4/3, give me negative 53.130. And now that's here. Is that between 0 and 2 pi? No, it's not. And 0 or 360, because in this case we're going to have degrees. That's okay. And so we're going to have to add 360 to get to our original, right? Why 360? This is the right quadrant, but it just doesn't fit the value. That's why we're adding 360. Normally it's 180. 180 is the opposite direction. So in this case, and also 3 minus 4 is quadrant 4. So we get 5, 306.87 degrees, right? Negative 53.13 plus 360 give us that. And then to go the opposite direction, so it would be minus 5, but then we got to subtract or add 180 to our theta. Why did we choose subtract? If we added, we'd be over 2 pi, right? 2 pi is 360, and so subtracting was the answer. One last part we have, and this one is converting from polar to rectangular and vice versa, right? Generally, the same formula is true. X is our cosine of theta, y is our sine of theta, and x squared plus y squared is r squared. So you would substitute, if you get r squared, x squared plus y squared there. If you do not have r squared, try to manufacture it unless it's in one of these two forms. Right? If you have r cosine of theta, we're just going to plug in x. R sine of theta, plug in y. If you have r equals, say, like 6, try to make r squared, and then x squared plus y squared equals that value. You also need to remember tan inverse of tan of theta is y over x. Pardon me, I had a mistake there. Y over x. And so we can do tan inverse if we need. From rectangular to polar, right, we're given the xy, we want r theta, right? Just substitute r cosine of theta for the x, r sine of theta for the y, r squared if we happen to have both x squared and y squared, and you solve for r or r squared if possible. Sometimes it's not possible and we'll just leave it. It is not simplified if you try to solve for r by dividing by r, or if you have r on both sides of the equation. For example, r equals 7. Again, I mentioned we want r squared. We can't really do much with this, so when we square it, we get r squared is 49, and then we're plugging in x squared plus y squared for that. So that's why you already see the squared here. R squared is 49, so x squared plus y squared is 49, and that is our final answer. R is 2 cosecant of theta is the same as r is 2 over sine of theta, but now we want to have it so that we have r sine of theta. So we're going to cross multiply by sine on both sides to get r sine of theta is 2, r sine of theta is y. So then we get y equals 2. One last set. Now we're going the other way. We're going from x and y to r's and theta. This one I see an x squared plus y squared, so I'm going to sub in r squared. When I see a y here, I'm going to sub in r sine of theta. So we've got r squared minus 10y, and then I sub in r sine of theta for the y. We cannot solve here, right? We can't plus 10r to the side, divide by r. You don't want it on both sides, so we just leave it. So if it doesn't look like you can clearly solve for r in a legitimate way, right? X squared minus 10x, you wouldn't divide by x, right? So in this case, we would just rewrite it and call it simplified. So if it doesn't look like you can solve it nicely, just leave it. This case looks a little messy. We got 3x minus 6y plus 2 is 0. Our cosine of theta, our sine of theta, so let's plug it in. And then this case, we could move anything that doesn't have an r to the right, so subtract 2 from both sides, and then we'll have pieces that both have r that we can take an r out of. So that's what we're going to do. We've got 3r cosine of theta minus 6r sine of theta is negative 2. Divide by r, I get 3 cosine of theta left. Divide by r, I get minus 6 sine of theta left. And then we're just going to divide by that on both sides. And that is our answer. Doesn't look nice and pretty, but it is an answer. And there is your homework for this lesson.